Hi guys, so in this video we will be learning a little bit more about the integrating factor questions. So I'll be working on some more examples basically. So let's take this example. X times dy by dx plus 2 times y equals to x squared. X is not equal to 0. So what you will what you would want to do, you would want to create that form which is dy by dx plus p times y equals to some q, which is a function, which is either a constant or a function of x, right? So let's just write it down in that form. So when you will write it down in that form, we will divide throughout by x. And this is what it will look like. So clearly what your p is here is 2 by x, and clearly q is x. So p is 2 by x. So which means that the integrating factor clearly is e to the power integral p dx, which means it is e to the power 2 by x dx, the integral of 2 by x dx. So which means it is e to the power 2 times log x, because the integral of 1 upon x dx is equal to log x. And since you have log x here, since it's log function and you have 2 in the front, then you can take it up here and as a power. So this becomes e times log of x squared. And since e and log, they are entire of each other. So what you get the inverse of each other, right? So what you get, just x squared. So that means the integrating factor is x squared. So we will multiply throughout by the integrating factor. So you will multiply throughout by the integrating factor, and your solution will look like this: y into x squared equals to the integral integral x into x squared dx plus c. So it will be equal to y x squared equals to x to the power 4 plus c. X to the power 4 plus c. Just in terms of y, of course, what you will do, you will divide throughout by x squared, and what you will get here as a solution, y is equal to x squared by 4 plus c x to the power minus 2. So that's the solution out here. Next, let's take this kind of a equation. So y times dx minus x plus 2y squared dy equals to 0. So dy by dx is equal to y times y upon x plus 2y squared, right? So this is what you have here. Now, to make it look in terms of, to make it look like in terms of dy by dx plus px equals to q, let's rewrite it. So what we can do, we can just, instead of looking at dy by dx, we can just try to, since you have y upon x plus 2y square, so I would rather take it as dx by dy, because it will be easy for us to write it down in terms of, in terms of something looking like this: dx by dy plus p dash y equals to q dash. So dx by dy will be x upon y plus 2y. Now, the integrating factor will be exactly the same way. The integrating factor will be, since p1 is minus 1 upon y, p1 is minus 1 upon y, so your integrating factor is e to the power integral minus 1 upon y dy. So hence it will turn out to be e to the power minus log y. That means, now since you have minus here, so you can say that this is e to the power log of y to the power minus 1. And since e and log are inverse, so this is nothing but just y to the power minus 1, or in other words, it is 1 by y. Multiplying throughout by it, remember this time you are looking at dx by dy instead of dy by dx. So it will be x into the integrating factor. So x into 1 by y equals to integral of 2y, which is your q1, 2y into 1 by y plus c. So integrating So this becomes x y, and here you have integral 2 y cancels. So you just have 2 dy plus c. So what you can do, what you can say, you can just integrate this. You have 2y, and then you can take y to that side, and the answer will be in terms of x. X is equal to 2y square plus cy. Okay. So this was a case where we worked it out around using dx by dy. Next question. dy by dx plus y times cot x equals to 2x plus x square cot x. So this time I've taken some trigonometry out here in the question. X is not equal to 0. And you would be required to find out a particular solution as well when y equals to 0, when x equals to pi by 2. So dy by dx to be written, so let's just write the equation in terms of dy by dx plus py equals to q. So p is cot x, clearly p is cot x and q is this expression. Let's quickly find out the integrating factor. It will be e to the power integral cot x dx. Now integral cot x is log of sine x. Integral cot x is log of sine x. And since you have log and e, so it just turns into sine x. So that means we will multiply throughout by sine x. So y times sine x equals to integral 2x sine x dx plus x square cot x sine x plus c. What I've done here is I've just, I've broken it up. So q is, or I can, if you want a better picture, so directly it is integral q is 2x plus x square cot x into sine x plus c, and in the next step I've broken it up, the sum. So this is what you get. So you have to integrate x sine x and 2x sine x, and see, you can just, cot is basically cos upon sine, right? So if you just mention cos upon sine here, sine side will cancel. Cot is cos upon sine. So into sine will give you just cos. So this is 2x sine x dx plus x square cos x. You can just, okay, there's another way that what you can do is just keep this integral like this and use islets here, by parts here, x square cos x. So this will give you x square sine x minus integral 2x sine x dx minus integral 2x. You remember, I hope you remember, it is 1 and 2. So 1 as it is integral of the second minus integral of the derivative of the first into integral of the second plus c. So this and this expression is the same, and hence this cancels off. This cancels off. You're just left out with x square sine x. So y sine x is equal to x square sine x plus c. So which means when I put the value of y and x, I can actually fetch the value of c, and this will turn into a particular solution. So we are given that y is 0 when x is pi by 4. So that means 0 equals to pi square by 4 plus c, or in other words, c is equal to minus pi square by 4, which means my particular solution becomes y sine x equal to x square sine x plus minus pi square by 4. Minus pi square by 4. You can get the particular solution just in terms of y for y. So y is equal to x square minus pi square upon 4 sine x. So that will be the solution here, particular solution here. And sine x, since x does not equal to 0, that's the reason why it was given in the question that x does not equal to 0, because sine x should not be equal to 0. It's in the denominator.